and this is the plastic mold tooling for the packaging industry. May I please welcome Mr. S.K. Jha, Head Mold Shop, Alpla Group. Pardon me for that. Ladies and gentlemen, could you please join me in welcoming Mr. S.K. Jha up on stage for this next technical session. Yeah. Hi. This is a clicker. This is front. This is back.
So, I hope now I think I am more comfortable together with you because we have our belly full. We had food and we have good energy level. If this was before lunch, then I would be also hungry and you too. So now it is a good one. So, first of all, I must thank Tagma for giving me an opportunity to be here and present the Elite Gathering, a basic technical presentation on specifically related to tooling, specifically for packaging industry. Sorry to apologize to the auto sector professionals. My presentation will have no relevance for them, but however, the basic tool making processes remain same. It may be specific to any industry. Okay, so moving on. This is the title, which was given to me by Tagma editorial board. Now, coming to the company that I work for, it's a European firm. The website ID is at the below of site. I hope all of you can see it. And the fact and figures reported in 2021 is we have close to 22,100 employees globally. We have 177 plants. When I say plant, that means these are molding plants spread across 45 countries in the globe. And our turnover is approximately close to euro 4 billion. In 2021, and the company was founded in 1955. But this slide has a very good catch. You see this, we have 177 production facilities. That means these are molding plants. When I say molding plants, it could be primarily extrusion blow molding plants, which produces extrusion blow molded bottles. Then it could be injection molding. Then it could be injection stretch blow molding or injection molding of preforms. The production facilities will have only these 4 processes. Now, when you see the number, you see 177 production facilities, then you see it is a big number. But to support this integration of these production facilities, we have 7 technical centers across the globe. And the 7th one is in Hyderabad, India, which was inaugurated or found, the 7th technical center of our company is in Hyderabad, inaugurated in year 2013. Now, so I told about 7 technical center, then we have 6 mold shops, totally across the globe, owned by our own company. The 6th one is in Hyderabad, inaugurated on 12th July 2022. Because of COVID, the inauguration was postponed for 2 years. Now we are operational. The plant was operational since Dasera 2020 onwards. But because of our European stakeholders could not travel, the inauguration has happened recently on 12th July 2022. Okay, now I have to also respect the time, so moving forward. So, most of tool making fraternity will know these classes of the molds. So you see the most top one is the most wanted one globally. That would be the elite cream layer of this whole classification. This is SPI classification. They will immediately know, the tool makers will immediately know which class they fall and which class molds they make. but this is a standard classification. And when we talk about injection molds or toolings, we only talk about class 101 mold. Other classes 102, 103, 104, and 105 is not relevant for my company at least. We don't want to have, or rather I would say, the below classes do not suit our business. So my aim is to talk about specifically that Indian tool makers are able to reach and able to make class 101 mold. That's my wish and dream. Hope it comes true. So now you see the image, the mold shop, that the whole greenfield project made by our company. It took us close to 3 years to make this from ground to what you see today in picture. This is close to 3,000 square meter or 30,000 square feet. It has 1650 square meter on the ground floor and 1350 square meter on the first floor. It's a very small tool shop. It's a very small mold shop. It is not aimed for commercial business. It's aimed and it's set up for captive business. Now, what services we offer? And I think now it is a time to laugh. You see, the timeline is too long that we take as a company. The whole mold shop, what you saw in the picture, is fully digital by design. It's a cyber factory, but still we take too long time to deliver a mold. And now I get back to the, out of this, in the mold shop, you see the most important function is missing. I have not written any text regarding sales and marketing, which means I start right here, which means we already have an order. We already have business. So we have business more than our installed capacity. So we don't have, in this mold shop, there is no sales and marketing department. We have orders that we can run this mold shop for next 5 years. That's not a problem for us. So we take longer lead time because, again, I put back, again I emphasize, because we only make class 101 mold. Many tool makers or many Indian tool makers or many global tool makers might claim that they build 101 class 101 molds. But when we say, we mean it and we meet the specification. That's the difference. Many would quote that we make class 101 mold, but when you try to verify, check, it may not qualify. That's the difference. Moving forward. It's a basic process that, I mean, my presentation is like, now if you see this sketch, it gives you a reminder of yesterday's presentation of the IIT professor. I don't remember the gentleman, the sir's name, who presented us presentation yesterday on 3D printing, some other subject I remember, and it was black and white and looking like a textbook. So this is a textbook of our process, textbook workflow sketch, how the injection molding works. And on the corner, near slide number, the output. These are caps and closures or rigid packaging output product which came from IM molds. You see the cap belong to a laundry care detergent cap. It could be, you can relate it to a product what you buy from Indian market called EG from Godrej. These are the, or Comfort from Unilever. So these are the cap which is laundry cap we call. So this is the basic system. Everyone is aware of what I hope. I don't have to, the plastic granule starts from here and you get the cap. That's everybody is aware, the whole people are aware here. I just put the background to the process. There is a video of the process. I hope it works. No, it didn't work. Can you play the video, please? Yeah. Thanks for the help on time. So this shows you how does the process work, and the assembled unit, which is closing and opening, is tool or injection mold, which everybody in this hall is aware about. I'm just showing a small representation in an animated form, which is for academic interests. Okay, moving forward. We can stop it here. Okay, this is the whole cycle. I will now move the slides faster. Everybody is aware about this cycle time, and cycle time is normally in seconds, typically in packaging. It could be bigger in other domain, but in packaging it should be in single digit. It's a typical picture of an injection mold. There is a moving half, there is a fixed half, or cavity side or core side. So the fixed half will give external geometry, moving half will give internal geometry to the part. Moving forward. Again, two basic type of molds, a basic slide, which everybody is aware. I'll just skip this. Some pictures of proto mold or quick, whatever you call prototype mold. Representative picture, then we have pilot mold. It could be 1 to 4 cavity. Okay, this slide needs more time. So, typically in packaging sector, you see we make molds we call production molds. It normally starts from 4 cavity and goes up to 144 cavity, and the same cavitations are also applicable for preform molds, which people would know it. Machine types can be hydraulic, I don't want to quote, it could be combination of hydraulic and servo, or it could be fully electric, which is now today. Let's say, when I say electric, that means we are talking in 2020 onwards, commercially. The clamping range, what we do in our business, range between 80 to 650 tons. Cavitation is directly linked to the volume requirement of caps annually. This will define the cavitation. Then surface finish can be gloss matte, resin type can be PPP. The cap can be mono injection, bi-injection, tri-injection, multi-injection, or co-injection. So there are technologies around. The bottommost is the different technology options available for making bi-injection caps. Bi-injection caps can be made by core back technology. In India, some people also call it punch back. The next is rotary table or turntable. That's the technology. Then we have spin stack. Then we have subtle. Then we have cube molds, which can be having 2-phase parting lines, or which can be having 4-phase parting lines. If you have 4-phase parting lines, then you will use, to spin the cube, you will use 90 degree, 180 degree, 270 degree, and 360 degree. Four positions during spin. You will have 4 parting lines. So for example, a cube mold has 4-phased. When I say, it will have 48 into 4, 172 cavities. And within our company, Alpla, you will be proud to hear that we are running cube molds made in Europe, because this technology is patented in Europe. It is still not available too easy in Asia. So we are running maximum cube molds within Alpla in India since 2006 onwards. Since 2006, since 16 years we are running maximum cube mold within Alpla group. Maximum cube mold is running in India. So that tells you that India can handle very, very complex technology, or Indians can handle. Then last is overmolding and tandem technology. Okay, I don't want to get into the detail of these technologies. Moving forward. This is the basic 2-plate mold. 1 parting line. Pictures. 3-plate mold. The second parting line is for runner ejection. One is for part. Typical picture. Then we have stipper plate mold. This is type of ejection, not a different type of mold. This is the picture of stipper ejection. The stipper plate will come forward, caps will fall. It's also called technically in India bump off. Then we have stack mold. You see now two level of parting line indicated by the arrow. So you will have 4 parts coming out from the picture that you see. If it is 4 cavity mold, 2 from one level, 2 from one level. You can have 2 level, you can have 4 level. So if you want to build, say, 400 cavity mold, you can make 100 cavities at 4 level. One stack mold will give you 400 parts per cycle. That's the approach. It is aimed for higher quantity production. This is the typical image of stack mold, how it looks like. You can see the picture. The parting line will open with a very complex units. Then we have a different type of side cam for specific design, geometry, ejection. Then we have, again, picture of it. This is unscrewing, everybody is aware about. It could be rectangular layout or sun and planet gear layout for threaded caps. You can see the caps falling out of unscrewing mold. These are the racks you see on top of mold. Pinion rack will make the unwinding and winding. Okay, this is now we are moving to hot runners. So you can have cold runner mold, where you will have runner wastage every cycle, which is almost getting obsolete. Now everybody is talking about hot runner mold. It can be semi-hot or it can be fully hot. A lot of speakers have talked about these products. I don't want to emphasize more. Semi-hot, you will get a runner still out of it. It is a combination of runner, cold runner, and fully hot. Okay, now you see, in the center of top line, you see bi-injection caps. Everybody is aware about it, that this is bi-injection. It is molded in a single mold. You see the cap that is having 2 colors, they are molded from the single mold. That's why it is called bi-injection mold. And this is my contact address. I think I have finished before. If anybody has any specific question on this presentation, they should feel free to ask me from the audience. Thank you. Thank you, everyone, for your patience.
Yes, sir, absolutely on time. May I please request you to join us in the center? May I please request Mr. D. Ravi to join us on stage to thank and felicitate sir for his wonderful presentation. Thank you so much, Mr. Jha. Thank you so much, sir.